they said that you would be able to appreciate. They were trying to figure out how to bootstrap what is essentially an industry that goes back to the Second World War into something more like Vermont, but also something that would take advantage of the sort of information and digital tools that are available. And one of the presenters made this interesting point that he said, it's not like we have to retool all these factories. What we need to do is stop the competition and start the collaboration, so that if a company needs to deliver a certain type or quantity of product and they can't make that within their own assembly line, they need to be able to team up with somebody who can. And I'm just thinking of how many assembly lines can't deliver what Vermont delivers. And for the short term anyway, right now, Vermont can't deliver just the sheer volume that some of these other. It'd be interesting to explore, if only academically, what potential there is in collaboration instead of competition.
Well, I'll tell you, that's our model for scaling up ZEM nationally. And that's what VEIC is doing right now. We have a factory in Delaware that's rolling this product out. We're over in New York State working on a feasibility study there. We're about to be working in Massachusetts on rolling out this program. And the idea is, of course, that Vermont at one home per week in their current facility is not going to meet our demand. They're not going to meet our Vermont, Northern Vermont demand, is my hope in the next couple of years. So the idea is a network of ZEM pop-up factories, all of whom are working together, not only in regards to helping each factory meet various orders if it goes beyond their ability, but the innovation, right? All the learning. So right. If you learn over here how to optimize whether it's something in the front office or on the factory floor, or it's a service agreement that's rolled into the folks' sale price for the home, where they have the assurance that anything that breaks over the first 5 or 10 years in the home will be taken care of without having to worry about it. I think that those things will be passed on to the rest of the ZEM network. So, I think that's key. With the current modular network out there, it isn't all that collaborative right now. That's for sure. And there's also, it's just, unfortunately, a big part of the modular manufacturing network is tied to the manufactured HUD housing industry. A lot of the biggest modular manufacturers are building trailers, and it's hard to distinguish the two.
Well, it's easy to distinguish the two, but people don't. I mean, it's very confusing for most people.
Yeah, I meant just what's coming out of their factory.
Oh.
Same level of quality control. When you go over to Titan Homes in New York State, there's still, you think that the plant's in like high speed, because these guys have a certain quota in the day, and when they're done, they can leave. And it's just like, how fast can I put this roofing on?
Right.
Or put these fiberglass bats in the walls.
In the undersized walls, and get the wheels on. Get the thing out the door. No, it's true. I think, is Titan, are they owned by Clayton?
Champion.
That's right, Champion. Yeah. So they're across they're like coast to coast. They have factories all over the place.
They do. Yep. Yeah. And they're the last manufactured home manufacturer in all of the Northeast.
Right.
That's it. Everything closed up in Maine, and now everything will come from Pennsylvania or Indiana, or then you're going down south into Alabama.
And so, interestingly, Champions also purchased a lot of the trailer parks that these products go in. And I heard, I don't know if it's true or not, but I heard recently about a farmer who wanted to buy one for this is a typical situation where you want to buy one for your kid, put it in a corner of the farm so that they can continue to live on the farm. And Champion wouldn't sell it to them because they said, no, we only sell into parks. Have you heard that trend at all?
No, but Clayton is actually the one that started buying up not only trailer parks, but more of these permitted huge developments all over the South and the West, where they buy them up and then and then they just fill them up with their homes. And Clayton, as well as Champion, just transitioned to doing they are transitioning, I should say, to doing all their own deliveries as well. So everything was outsourced before, right? They were working with developers to sell their homes. They were working with a transport company to deliver them. Now, Warren Buffett is pulling everything, or at least whoever's running Clayton is pulling everything in-house.
Right.
And on the mobile home park side, unfortunately, yeah, it's become a profitable business to get into, and mobile home parks are getting snatched up by everybody looking to make money on, vulnerable populations. And fortunately, in Vermont, Delaware, there's a handful of states across the country that have protections in place that, the tenants have the first right of refusal if a park goes up for sale. And then it's a nonprofit like, the Champlain Housing Trust.
Oh, really?
And that's what we're seeing. So the last, there's been 40, 50 parks in Vermont that have gone up for sale, and pretty much all of them have gone either to the tenants or the nonprofit. And I'm hoping that's a trend.
Do you know the fate of the one in Waterbury that got done after the flood? Do you know that one?
Yeah, I do. I don't know.
Yeah.
I
mean, I tried to help it was a very small time developer, and I tried to help him. I gave him a lot of free design ideas and tried to steer him towards a community solution that would, produce actually a neighborhood and not a product. And then I've been down here for a while. I drove by it the other day and I was horrified.
Oh yeah. Well, yeah, that's how I feel about most of them. But fortunately, I mean, even our Vermont State Housing Authority, they own 20 parks, and they're motivated to fill them up with zero energy modular instead of manufactured homes. They've got 150 vacant lots, where they're losing about $300 per month per lot on rent, because either there's an abandoned home sitting on it or it's a vacant lot. So we've got our stakeholders in line, understanding the value of putting a real home where you can get an actual mortgage instead of a chattel loan, 15 year at, 10 or 12% interest rate, through one of these manufactured housing dealers.
Right.
So we're making headway. And, again, my hope is that we're doing this nationally. We're just trying to prove the model here.
We're going to probably start up pretty soon here, but let me leave you with this little bug in your bonnet. If you're working with any of those efforts to revitalize the parks with Vermont, if there's a place where Yestermorrow can help out,
yep,
or build something that it wouldn't probably be, well, it would be built on site and ship, but that's that would be a great project for Yestermorrow. So
perfect.
Just keep it in the back of your head. If there's something that comes up, I'd love to see it. I'm trying to figure out a way to get a plain vanilla box donated to the school, or a couple of them, so that we can run hands-on courses. Right now, this is all we run, and it's not in our tradition as a school, which is to be a hands-on educational.
I will plug the whole thing.
So anyway, Gio, why don't you cut me off? I'm going to blab on forever if you don't.
No problem.
Hi, Carol.
Hi, I'm moving.
Hi, Ron.
Hi, John. Hi, Gio.
Hey there, Ron, Carol.
With all these people, I'm gonna maximize my screen now, just so I can see them all.
Mark, how's it going?
Good. How you doing?
Fine, thank you. Great. We got 3 out of 6. 3 more.
I don't see Mark. Where's Mark?
How can you not see him? He's right there.
Oh, there he is. Hey, Mark.
Hey, John. How are you?
Very good.
So, while we're waiting, John, I sent you an email asking where the modules are made that you're, I guess, I went to your website. Tomorrow Studios. I forget exactly what it's called.
Right.
Who makes your modules?
Well, I'm have shopped with a lot of different companies. Did I not send you an email that listed all the companies that I've bought from over the years?
No. Or
Well, I thought maybe in any event, the first building I ever did, I got from CSI, which was the biggest mod fabricator in New England, and they promptly went out of business literally the next day after the set of the. So I don't
better than the day before.
Maybe I actually had another order in the day before that one. We had to go under cover of darkness and retrieve our windows because once you declare foreclosure, the banks and the Feds just closed down the place. So that was interesting. But on a more upbeat note, I've built, and we have built ongoingly with KBS and PBS and well, back in the day, New England Homes we built with, and of course we've built with Connor Homes, and then we feel like we've built with some other companies simply because we've been in their factories and run so many respective jobs through their estimating department. So you're going to hear tonight about a new and brilliant facility in Vermont called Vermod, which our guest speaker is going to present. And I would probably aim you towards that as a first choice. We're involved with a project. We're trying to get Vermont to build one of our houses right now, one of our designs. So it's putting my money.
Yeah, I like Vermont. I've talked to them in the past.
Well, we've got one of the midwives who helped Vermont come to existence, and Peter Schneider tonight. Peter, I think we're going to let you have the first part of this program so that you don't have to spend the whole evening here. I'm embarrassed to say that your credentials have grown too lengthy for me to know them all anymore. And I knew Peter way back when he was the brightest and the most visionary individual at Energy Vermont, right?
Efficiency Vermont.
Efficiency Vermont, right. And since then, he's had his hand in just about every project and endeavor available to try to reduce or clean up our energy use in the state of Vermont, and as an example, more broadly. And the reason he's here tonight is because he, I believe it was your idea, was it not, Peter? The Vermont, yeah. So he basically came up with the idea of why not solve a big part of the energy problem in the state of Vermont as well as a housing situation by jump-starting a company that really addresses energy with all we currently know about how to produce net zero buildings. Peter's also had a long history with net zero buildings, passive house, and not just homes, but other much bigger buildings. So his command of the science and the building science behind this is remarkable. And Peter, I'm sure I've left out a whole bunch of stuff, but in the interest of your time, why don't I hand this over to you? And
Great.
And I'm going to be interested in just listening.
Thanks, John. And thanks, Gio. Thanks for the invitation, and appreciates everybody's interest in this topic. Everybody can hear me okay?
Yeah.
Great. So yeah, I think that honestly, my resume gets shorter and shorter each year because I have to drop off various things that I've done to focus more narrowly on right now is really low income and high performance modular. And so I'm going to share with you a little bit of what we're doing. I'm going to focus in on a case study of a mobile home park that we redeveloped as a zero energy community. And I think that it, in part, not only is that a model that I think we can replicate across the country, but also the way in which we're producing and delivering these homes is fairly innovative as well. And it sounds like aligns very closely with what you've been learning to date in regards to prefabrication of homes, factory built homes. So I'm going to pull up my screen and just go through some slides. And I want everybody to feel very comfortable to interrupt me at any time, and I can go into more depth on a specific aspect of this PowerPoint. And if not, I'm happy to answer any questions at the end as well. So let's see. Let's see if this works. Is that working for everybody?
Yeah.
Okay. So I'll get into what McKnight Lane is, but a little more background on myself is I work for Vermont Energy Investment Corporation. I'm an energy consultant with them. I've been there for a little over 16 years. I came to VEIC to implement a locally homegrown green building program. So for about 3 years, I certified almost exclusively worked on homes that were designed to meet this Vermont Builds Greener standard. And then Vermont Builds Greener, along with, the City of Austin's green building program and a couple others were used to develop the LEED for Home standard. And we shelved Vermont Builds Greener to take on the Northeast, all of New England's implementation of LEED for Home. So we were the lead provider for the homes through the pilot phase, and that went on for a couple of years. And then we really started to focus in on Vermont, and we started to focus in on energy, and which led me to Passive House. And so I started transitioning from doing more green building certification work and design assistance and performance testing and site verification, and transition to doing a lot more modeling and a lot more detailed design guidance using the Passive House planning package and the Passive House energy standard out of Germany. And so we certified, interestingly enough, the first Passive House in New England in Vermont, and it was a modular home. It was the first modular Passive House in North America, and it was a low-income residence. We did it in partnership with Habitat for Humanity. And boy, I never turned back from there. That experience really, I'd say, solidified my interest in factory-built housing. And I just sort of ran from there. And the other thing that it did for me is I had been supporting a lot of market rate, higher-end green homes. And when I did that modular habitat project, I just felt like I wanted to exclusively work with providing better housing to our more vulnerable populations. And I've been fortunate enough to work in an environment where I was given that opportunity. So literally from that day, I've been really focusing on serving very low income home buyers and tenants and trying to get them into the same great green zero energy housing that a lot of of our moderate and more upper income clientele are getting into. So I'm going to focus in on just the opportunity here nationally to transition our mobile homes to zero energy modular. And so I'm just going to run through a little bit of background just quickly on definitions, and I'm sure John and Gio have gone into this, but really a mobile home or manufactured home or a trailer home, those meet a federally mandated HUD code that really doesn't meet any of our state's bare minimum residential energy codes for stick-built housing or modular housing. They sit on trailers. They're typically built in very large factories that are centrally located in Pennsylvania. Indiana, down south in Alabama, and over in the New Mexico region. And names like Clayton and Champion. The only factory that's left in the greater Northeast is in New York State, called Titan Homes, which is a division of Champion Homes. And so we feel like there's real opportunity to not just look at first cost, but look at total cost of home ownership. And I'll get into more detail on that. But we've got 22 million Americans in mobile homes right now. In the state of Vermont, 10% of our population lives in mobile homes. And most of these mobile homes are beyond their useful life. And in the background here, you'll see a good example of your classic mobile home park, very small setbacks, long linear houses. Most of these are somewhere around 12 to 14 feet wide, 70 feet long, 3 bedrooms, 2 bath. So what are the problems with this type of housing? They lose value over time. They're shown, you can look at their NADA Blue Book value. Day one, it's like a car. They're going to lose value, and they continue to depreciate over time. And the reason that so many people live in mobile home parks for such a long period of time is because they can't get out of their house. They have no value in it. They can't move up the ladder like every other homeowner does in typical stick-built housing, where their home either holds its value or actually appreciates over time. The homes are also residing on leased land. So they don't own the land that's underneath their home. They pay rent every month. You can see they have a short lifespan. They're very poorly built, high energy costs, which can be a real burden on a month-to-month basis, not knowing, what's going to happen. There was a great article in the Washington Post 2 weeks ago, which actually highlighted mobile home park residents in Vermont. And it was all about how this last December, a lot of people who get fuel assistance already burned through all the $500-600 in fuel assistance that they get, which is supposed to help them keep their homes comfortable throughout the winter. And they had already burned through that, trying to keep their homes comfortable in frigid early December temperatures. So good example of what I find out in the field. We've got a real old wall system there on your right. Look at that, 2 inches, These are not uncommon in parks, and I'll show you some pictures, but these exist out there. But the new homes are coming with ductwork that hang down in these bellies that are exposed to the outside air and to pests and rodents. And you can see this down in the bottom left, the ductwork they're putting in is prime territory for nesting. And then the materials that they're using in these plants in the top left, every manufactured home comes with a health notice on the kitchen counter about how if these homes get too warm, you may experience, burning eyes, itchy throats, respiratory issues because of the high formaldehyde and VOCs in the home. So there's an opportunity here to improve upon what we're doing today. It's not just the older homes. So here's Clayton Homes. They own 66% of the manufactured home market. This is Warren Buffett, Berkshire Hathaway company. And this is your classic manufactured home dealer lot. You come in there, it's everything, turnkey. They manage the financing of the home. They'll get you the insurance, and they'll sell you the home, deliver it, install it, and they even have lots and mobile home parks that they own. So it's very turnkey, and it's something that is hard to replicate in regards to the simplicity. But what we need to do is provide a better outcome with an easy sale like this, instead of getting folks into a depreciating asset that has all sorts of health and longevity issues, and get them into something that's going to help them move up. So what we've done is we defined a new way to build homes. And I'll just say this came out of a natural disaster, Tropical Storm Irene, which hit us a little over 5 years ago. We lost over 400 mobile homes around the state to that severe weather event. And it was a real catalyst for how are we going to, at that time, rehouse these displaced families? How are we going to replace this housing? And fortunately, Efficiency Vermont, our state's energy efficiency utility, was brought to the table to be a part of that discussion. And I was adamant that we could not promote manufactured homes to replace these mobile homes, that we'd just be back in the same position we are today 5 years, 10 years down the road. Fortunately, we had a lot of forward-thinking folks at the table from the state and our affordable housing agencies, and we had the support of our weatherization agencies that were like, you should see what we see firsthand out in the field. So we developed this zero energy modular product out of that, created a RFP, a request for proposals, to do 10 pilot homes around the state in regionally distributed mobile home parks. You can see one of these units here. Vermod, V-E-R-M-O-D, they arose out of this opportunity, literally moved into an old FedEx warehouse. And I call it today a ZEM, Zero Energy Modular, pop-up factory. They literally opened up a factory and started building those homes when they won that contract for 10 homes. And Zero Energy Modular, I'll go into more details about the characteristics of that home, but you can see, we're really talking about craftsmanship, long-term durability and resilience, fresh air ventilation and healthy material selection, and then long-term affordability in regards to high levels of energy efficiency, and then something that's going to hold its value at the very least, if not appreciate over time because of the quality of the product. So there you go. We're talking about at least a 100-year home, just like any other stick-built home should be built out there, or custom modular home. No energy bills. Every home's all electric. They're going to come with solar on the roof. So we're getting folks into a fixed payment every month. So to jump into a case study so you can really see this firsthand, this is 3 years into our program. We had an affordable housing organization called Addison County Community Trust. This is, if anybody's familiar with Middlebury and Middlebury College, this is right between sort of Middlebury, Vermont and Burlington, Vermont. Waltham, Vermont is a real small town. They had no affordable housing in the town, but they did have an old mobile home park with 14 deteriorated beyond their useful life mobile homes. The park owners were open to selling this park, and fortunately Addison Community Trust engaged with them, signed an option to purchase it, and they turned this project into a full redevelopment, just like a typical affordable housing multifamily project, but this was going to be redeveloping a mobile home park into a healthy, sustainable community. So you can see in regards to what we're dealing with up here in regards to temperature, we've got 7,500 heating degree days, design temp of -4 degrees Fahrenheit, though in Waltham 2 weeks ago, we were at -21 degrees for 36 hours. Solar radiation, below 4 kilowatt hours per meter squared per day, but that's still great for solar, much better than all of Western Europe. So there's no reason we shouldn't be putting solar on our roofs in climates like this, even though we're the second cloudiest state in the US. And you can see the design load. So at -4 degrees, we're talking about 7,000 BTUs per hour. And if anybody's familiar with heating loads, that's very small. We're getting down to, this idea of just needing a hair dryer running to keep a home warm. But that is with our zero energy modular standard. So this is how we get there. We have R40 walls, R60 roof, and R30 foundation, which in this case, we move our thermal envelope, so our insulated envelope, up to the floor. And we actually have an R40 floor that separates us from our basement area. 1 air change per hour at 50 pascals, so that's the air tightness. That's 3 times tighter than our typical Energy Star home. And our manufacturer here in Vermont, Vermod, they actually cut that in half. So most of their homes are below the Passive House air tightness standard of 0.6 ACH50. So very tight home. We're talking levels where you can hardly find the leaks in the home. So we've really made these super airtight to eliminate any concerns for drafts or heat loss to the outside via air. Windows, an R5 window, we've played around with that a little bit. This is the 0.21 window is honestly, it's just, in the market. It's far more available than a window that gets you down into the R7 level, which is like a passive house window. But again, we are working in the affordable housing market. We're trying to keep these homes affordable. So this is about cost optimization and overall performance. But an R5 window meets our goals, which is to ensure high levels of comfort and low energy use. You could always put in a better window. They're out there. You can get them in the US now. They used to be all available out of Europe and Scandinavia. But that's a good window. HRV, so heat recovery ventilation or energy recovery ventilator. In Vermont, for our zero energy modular program, we require an efficiency of at least 75%. So that's the sensible recovery efficiency. That just ensures that we're getting real high levels of heat recovery with that outgoing airstream contributing to that fresh air coming in from outside. All Energy Star lights and appliances, the EPA Indoor Air Plus standard, because it doesn't matter how energy efficient your home is, if you fill it up with a bunch of toxic materials, you're still doing that homeowner a disservice. So air quality is just as imperative as our energy efficiency standards. And finally, Watersense, just being really smart in regards to our water use. There's no question you can get suitable flows that nobody's going to complain about with your shower heads and your faucets and your kitchen sink, as well as your washing machines and dishwashers using Watersense EPA certified equipment. So this is what our system looks like. To start at the floor, we'll have the I joist, TJIs, truss joists, 9.5 inches deep, dense packed with fiberglass. If you're looking up from the crawl space, you'll be looking at a Huber zip system, taped and sealed. So we have a true weather air barrier that's exposed to our tempered crawl spaces. We'll have a 4-foot typical home, a 4-foot crawl space, 8-inch poured concrete walls with a 2-foot footing, perimeter drainage to daylight, drainage down the middle of our crawl space as well, with a 10mm plastic on top of that, sealed to the walls. Hermetically sealed, airtight space, no insulation. That space over the period of our winter, even under the harshest conditions, going into January, February, that crawl space will never go below 35 degrees. I've been monitoring these homes for 7 years now, so we don't have to worry about pipes freezing or sewer pipes freezing. It's a tempered space. That's a combination of ground, thermal energy coming up, but also a little bit of heat loss through that R40 floor. Our walls are a double 2x4 wall, very simple, just 10 inches wide. So you have a 3-inch airspace in between your two 3.5-inch studs, 24 inches on center framing, dense pack that with fiberglass at 3.4 per inch R value. So we're getting an R43 wall there. Huber zip system on the exterior as our air barrier and weather barrier. And then we have, for our roof system, we have different options there, but for the most part, we're putting a SIP panel as our roof, and I'll show the installation of that. We use a Neopor, which is a graphite-infused structural insulated panel. It's expanded polystyrene, one of the most environmentally friendly foams in regards to its global warming potential. Has a R5 per inch, so we have a 12-inch SIP on the roof that is taped and sealed to our wall. Our wall is taped and sealed to the floor, and that's why we get the air leakage numbers that we do. These are really airtight homes due to real high performance, double gasketed windows that are casements and awnings, combined with, a really airtight envelope with a real defined air barrier. If I go back to this picture, the one ACH picture, you can see that red line around. You want to define your air barrier and be very critical in regards to any places where you're going to have a jog in your assembly, because that's always a difficult place to ensure that you're going to eliminate air leakage. We stick with very simple geometry, and we have very detailed, simple air sealing details to connect everything. Let me just add one other thing, which is we use 5/8 inch sheet rock. Everything is glued in the factory because we're delivering on average a 14 by 70 foot home. We have 4 picking points, so 4 cables at every 14 feet under that home when it gets to the site to lift it up off the trailer and set it down on the foundation. So we need those homes to be really durable. So 5/8 inch sheetrock glued to the studs, as well as our Huber zip system is glued to the studs. So just, we've gotten to a point now where the homes are delivered and there isn't a crack in them. And that's been some lessons learned along the way of what works and what doesn't in regards to various details. But that's where we are today. And, it just reduces the amount of time and effort on site to patch things up. The other thing I'll mention is that we have a super insulated assembly here, and you can't ignore how a thermal envelope handles moisture. So I'll just say that what we do here is we put a vapor barrier primer on the interior of the sheetrock. If you can imagine a 14x70 home with no interior walls, but it's fully sheetrocked, we create a tunnel. Everything's taped, mudded, and sealed interior before any interior walls, before any soffits, and they spray a full vapor barrier primer on the whole interior of that home. What that does is it eliminates vapor drive into that wall system during the winter, so you don't have concerns about condensation, water vapor turning into water droplets on the exterior sheathing. You have to be very thoughtful when you get into a super insulated envelope, because in a typical 2x6 or 2x4 wall, that exterior sheathing is pretty warm in the winter because you have so much heat loss. It's hard to achieve your dew point where your water vapor will condense into water droplets, causing potentially mold and mildew and structural issues. In a super insulated wall, you're going out to R43. The outside sheathing is really cold, so it's very easy to get to your dew point if you have bulk moisture or even high vapor drive moving to that outside sheathing. And unless you're putting on a fully vapor permeable exterior sheathing, you're gonna have condensation on that exterior sheathing. So what we do is eliminate vapor drive to the outside. We can do that because we're working in a climate controlled environment. The whole home is sheetrocked before the exterior sheathing and insulation is installed, right? And so we can come around and run our electrical outlets and the electrical and air seal all those outlets and make sure everything is buttoned up perfectly before we insulate and sheathe the outside of that home. That's the beauty of a factory built home. So there's a good example of it. They're going to run the wiring down low in that double 2x4 wall. You can see some wiring up in the wall already. Then they'll put that second Huber zip system panel on that will go from the floor, the bottom of the floor there, that rim joist, up to that cloth. And that cloth is where they're going to dense pack in that wall. Start at the bottom, move to the top. They go with a wider diameter hose first, and then they come back and they dense pack to about 2 pounds per cubic foot. So that's like that shape, like a basketball. And so we're putting 2 pounds per cubic foot in there. Some may ask why we don't use cellulose. It's far more environmentally preferable in regards to its recycled content. The reason we don't is because cellulose goes in at 4 pounds per cubic foot, and we get into more expensive trucking. We get into bigger cranes when we add that 7,000 pounds to our average house. Fiberglass goes in at 2 pounds per cubic foot. The other thing to think about is we can only travel down the road at 16 feet wide. Fiberglass is, as I mentioned, are 3.4 per inch, and our cellulose is less than that. To get the same R value in our wall, we'd need to go to a 12-inch wall system instead of a 10-inch wall system. So every inch really counts when you're talking about a 16-foot wide home. Here are our windows. We've been fortunate to partner with a window manufacturer right across in New York State called PVC Industries. They make the Earthwise product. This is actually a national line. There are a number of window manufacturers that make this product, but it's a great vinyl, triple glazed, airtight window. We exclusively put in casements and awnings. We do not put in double hung or single hung windows because we don't want to rely on the poor air leakage characteristics, or air sealing characteristics, I should say, and the higher air leakage associated with windows that slide on a track that rely on a single gasket at the sash. With these compression type closures, where the window is actually pulling shut and sealing 3 gaskets on each of those windows as they shut to ensure a real airtight fit. And that's one of the reasons we get our airtight seal. And you can see we have a flanged window installation. It's very simple, very easy. 6-inch zip tape that integrates right into our air barrier and weather barrier assembly, and that's it. Are there better windows and better window installation details? Yes, but they are much more expensive. As you get into windows that install with straps that you inset in a window and over insulate like you would in a passive house, you're getting into twice the cost per window in regards to parts and labor. And we just can't afford that today to get to the price point we need to be at. Sorry, going the wrong way. So there's a good example of that, that continuous air barrier on the inside of the home. Sheetrock the whole thing, then put in those interior walls. So there are SIPs. So those SIPs are 14 feet long by 4 feet wide. And you can't see it, but there's gray expanded polystyrene foam behind these TJI. So on one side of each SIP is a TJI, a I-joist that locks into the next panel. So I'm going to just see if this little video plays here on the right. And that's how they're installed. You can see how they have the spray foam already, and it's locking in to that adjacent SIP panel. Everybody see that? I can do it again. So pretty cool, really simple. And yes, that's in high speed, but boy, they put a roof on really quickly. And then what they're doing is a single membrane rubber roof on this. And so that ties right into the zip wall on the side. So we have this nice continuous air barrier all the way around. So this is how we get there in regards to, we've now reduced, we've focused on conservation, and we've really nailed the thermal envelope, the air infiltration. Now it's okay, how do you serve a home this size with that low of a heating and cooling load without, you know, cooking the people out of the home or having a piece of equipment that short cycles all the time because it's oversized. So this is our system. We have a cold climate heat pump. Some of them know as mini splits. I'll show them, but that's a wall mounted unit. In this diagram, they show it in like an end bedroom. We put one unit typically in the main living space. We have our conditioning energy recovery ventilation system in a dedicated mechanical room, heat pump water heater, battery storage for resiliency, and then our solar PV on the roof. So that's sort of our mechanicals. And I'll go into detail on each of those. So here's what makes our home healthy and comfortable. We have this serve ventilation system, and I'm going to not go into too much detail here and just strongly encourage everybody here to check out buildequinox.com. Ty Newell there, Ben Newell, who run it, they have some fantastic webinars where you can learn everything you'd ever want to know about indoor air quality metrics, the serve, the new version 2 serve, and you know, basically how we ensure occupants are living in a healthy environment that'll lead to higher productivity and better health outcomes. What the serve does, though, that's really innovative, and you're not going to find another product like this on the market, is it not only is ensuring high levels of indoor air quality in the house, but it also provides conditioning. So it has an inline exhaust air heat pump. When you look at the little diagram in the bottom left, part A, that's a compressor. That's an evaporator and a condenser. The little gray sort of circle there, that is the expansion tank. And that actually is pulling heat in the wintertime out of the exhaust air before it goes outside and putting that energy into the supply air. So on a day like today, up here, we're, what are we, 15 degrees right now? That air is going through there, say like 50 degrees. It's going to pull out another 25 to 30 degrees out of that air, and it's going to put it into that fresh air supply stream that's coming in at 70 degrees, and it's going to deliver 90-degree air to the house. So our remote bedrooms, instead of your typical high-performance HRV that on a day like today is going to deliver 60-degree air to those remote spaces like your bedrooms or your living space, we're delivering 90-degree air there. So what we're doing is we're mixing the air and we're actually conditioning it to ensure that we have high levels of comfort in all spaces. You know, it's not the classic high-performance home where, or even, you know, our typical Vermont farmhouse that has this really warm core, but then you have these really cold remote spaces. The Serve ensures that you have high levels of comfort throughout the house. The other thing that it does is it doesn't just bring in fresh air continuously, assuming that ventilation is needed. When nobody's at this house, it's not going to be bringing in fresh air. If there is low occupancy at the house and the air quality is good in the house, it's just going to recirculate the air inside. It's not going to bring in fresh air from outside. It is measuring the carbon dioxide levels, what we expel, and the VOC levels in the house every minute as that return air comes back from the house. So we have exhausts in our bathroom and kitchen area and our laundry room, and we have fresh air supplied to the living room and bedrooms. That return air coming from our bathroom, kitchen, laundry is evaluated when it comes back, and the Serve decides what it needs to do. If that air comes back cooler than the set point, it will heat the air and send it to the house. If it comes back and the CO2 level is above 1,000 parts per million, where we set the threshold, it will bring in fresh air from outside. It will either preheat it this time of the year or pre-cool it in the summer and deliver that to the house. So it is ventilating as needed, not over-ventilating or under-ventilating, which is really the go-to strategy these days with homes. And I can come back to that, but I do encourage you to go to Build Equinox and check that out. Here's our cold climate heat pump. All sorts of heat pumps on the market these days. Been very happy. The first heat pump I put in as a primary heating system without a backup was that Habitat for Humanity passive house. We have actually 3 of those houses side by side. We're going on 8 years later now, and these systems have been working flawlessly. Really great, low maintenance, very high levels of efficiency, both on the heating side and the cooling side. I will say that with our more extreme weather, I am now putting in a backup system in our zero energy modular homes. As I mentioned here in Waltham, we had that negative 21 degree day. Up in Hardwick, Vermont, where we have 11 of these homes, it was negative 27 degrees. And we had a number of these units shut off. They shut off at negative 18 degrees Fahrenheit. They're producing plenty of heat at that point, but they have a shut off. That's just a built-in algorithm. And so typically we've experienced that real cold blast for a short period of time in the middle of the night, and then these units would come back on. Honestly, I've never seen them shut off. But we had that real extreme cold snap. They shut off, and they didn't come back on until midday the next day. The way they're set up is they won't come back on until that thermistor in the outside compressor, the fan unit outside, is at negative 14 degrees Fahrenheit. So that was a little wake-up call in regards to the vulnerability of this system under these real extreme conditions. But what was really nice about our home is that we have the Serve. And the Serve is actually designed to support an auxiliary heating system. So for $500 parts and labor, we were able to pull out a little bit of flex duct. Let me just go back to our picture there. On the left side of the screen there, can you see my cursor?
Yeah.
Yeah. So there's a little bit of flex duct here. And that's just an acoustical bat. And we have that on every installation just to reduce fan noise going. And this is on the supply to the house. Every house we went out and we just pulled out that flex duct and we put in a 3 a 3 kilowatt duct heater. And we were able to run that control line right into the serve. And the serve on its little controller, you see in the bottom left corner here, they have a touch screen that's wireless that'll sit on your kitchen counter. They have a screen on there that you touch on, and it's an auxiliary heater screen. And you can set up for that auxiliary heater to come on whenever your temperature in your house is a certain number of degrees below your set point. So we were able to just install a duct heater that provides a full heating backup if anything ever happens to that heat pump. And this will deliver enough heat to the house to keep it 70 degrees under negative 25 degree Fahrenheit. So that was nice. You know, some houses aren't going to have the flexibility we do because we have the serve installed, but we have a pretty robust system now that ensures that, you know, that higher level resilience. If we have these, you know, real deep troughs in our, you know, our weather pattern coming across like we had back just late December, early January. So again, great performance here. You can see when we're at negative 13 degrees, we're still putting out over 70% of the output of these units. They're amazing. These refrigerants they're using, and they're only getting better. You know, it's going to be next year, I believe, where we're going to have negative 20 degree units out there that are putting out the same performance with much lower shut-off threshold. So I'm really excited about that. I don't hesitate to utilize these as primary heating systems, but I do think that if you don't have a wood stove in your house, like we don't put any wood burning appliances in our houses because they're just too efficient to handle that amount of BTUs. Putting in a little bit of electric baseboard as backup or a inline duct heater is a simple solution. Heat pump water heater. I just saw a great graphic today at a conference out in California that I attended via webinar just like this. You know, you start looking at the cost of a heat pump water heater and then a high efficiency gas water heater and a standard electric resistance water heater, you know, all 50 gallon that look just like this. They're all in the, you know, $1,000 to $1,500 range. But this one's 350% efficient. The gas heat pump water heater, 67% efficient. And of course, the electric resistance is 95% efficient, but it'll kill you in cost. So it's really a no-brainer these days to integrate a heat pump water heater. We're doing it in a very small mechanical room. We actually bring air in from the rest of the house to keep that mechanical room tempered so it doesn't get too cold. And in the late spring through the early fall, we get free cooling and dehumidification. The serve takes the exhaust air off this heat pump water heater, which is dehumidified and cooler air, and it actually delivers it to the house. So we rarely ever need any cooling to keep our houses continuously at a lower humidity than outside and at least 5 to 10 degrees cooler. Our 6,000 to 7,000 watt PV system, we do on our homes. Again, this is the economics of building low income housing, but we want to deliver a turnkey home that's done. Many people, we are displacing them for 3 weeks while we recycle their old mobile home and we get this new one in. So we need to do the site work and deliver this home. Most of our homes will travel down the road 100% finished. So we need to be under 13.5 feet. Otherwise, we hit bridges in Vermont. So you can't travel down the road over 13.5 feet. So that impacts your ceiling height and your roof pitch. Most of our roof pitches are around 2.5, 12 pitch. So, you know, 10 degrees. And so we have a sort of a commercial solar installation with regards to it's pretty much maximizing output spring, summer, and fall, and we're not worried about production in the winter. When the sun's really low in the sky, it's cloudier and we have snow loading. So just to answer that question right off, our systems, instead of putting out, if we have a 6,000 watt system as just shown here, this system will produce about 6,500 kilowatt hours as opposed to about 7,000 kilowatt hours on that perfect 30 degree pitch that faces 195 degrees south in Vermont. So there's a little bit of a compromise, but this is a much less expensive installation than the one that you're putting on that perfectly pitched roof. It's much easier in regards to they're walking around on the roof up here. It's a rubber membrane roof, and we actually use these adhesive back anchors for our racking system that are literally just stuck on in a grid, and our aluminum racking screws right onto those adhesive back anchors. It's really, really elegant system. They install this system in a few hours as opposed to a couple of days in the factory, a couple of days in the field. So let's talk about cost. I'm a huge fan of old VW ads, and I encourage everybody to check them out on, Pinterest or any of the eBay even has a lot of them for sale. But this is one of my favorite, and actually most of their ads are applicable to zero energy modular. This one, a new VW, is cheaper at twice the price. Well, fittingly, a zero energy modular is about twice the price of a new HUD manufactured home when you're all said and done. But there's more to home ownership than just first cost, as everybody knows. So you can see here, we're looking at, about $200, $225 for a new manufactured home in energy costs per month. We basically roll that into the mortgage instead and provide a zero energy modular house. We also are able to get much better incentives for this house. We're able to get better interest rates and better terms on our mortgage than a manufactured home. So day one or month one, our homeowners have a much better cash flow on a monthly basis. You can do this for any of your projects as well, and you're going to find the same thing when you compare it to an alternative approach. That is when you look at energy plus mortgage, and we're not even factoring in better health outcomes, higher productivity at home because you're more comfortable, less stress because of fluctuating energy cost or a real cold December. All these things benefit the homeowner beyond just cash flow on a monthly basis. And, it's hard to put a number on the value of all those non-energy benefits, but they're there. And it's important to highlight those as you're pitching this type of housing. For us, as an energy efficiency utility, and we're doing this in a number of locations right now, the savings are extraordinary. A brand new manufactured home built to the HUD energy code is going to use 80 million BTUs per year. And we're not talking about all the existing homes out there that'll use 120 million BTUs per year. And I'll give you a good example of a phone call I just received from a mobile homeowner, but we're literally eliminating that. And that's the beauty of zero energy modular. There's no gray area here. We're just eliminating energy usage for that home. All the carbon footprint associated with that home. We're reducing peak loads at just the right times with our solar systems. In this development, which I'm describing now, we have battery storage that the utility can utilize the few times a month. They can discharge all the batteries in these 14 homes and reduce their peak obligation to the regional utility, which saves them money and their ratepayers money. So there's a lot of benefits from a sort of utilities perspective with regards to these homes as well, but certainly these savings are real to the homeowner as well. So you can see the flexibility. We can do anything with these homes. They're just boxes built in a factory. Yes, we have to be 16 feet wide and 13 and a half feet tall going down the road, but that doesn't mean you can't maximize those sizes and start putting these together, which we've done every one of these configurations you're looking at. So we don't just do 14 by 70. We'll do 12 by 24 foot boxes that are put together to put a home on an existing foundation that was already there. We're stacking boxes on top of each other. We're delivering a roof with a first floor home, which I'll show you. No limitations here. What's important from my perspective, and that is sometimes lost in the modular industry and in factory built housing in general, is moving too far away from what really works and can be optimized in a factory. You want to stick with simple geometry. If you can eliminate sheriff escorts, if you can eliminate the larger crane, all these benefit the final price point for that home. And it's just important to understand who your client is and to guide them to making these good decisions. At Vermont, they literally have 3 different marketing sections, book 1, book 2, and book 3, and they're for the different clientele that come in. Book 1 is going to be for folks who are just, they're actually working really hard just to get mortgage ready to buy that base home. Book 3 are the people who can come in and, you know, start putting homes together that and do levels of finishes that would be worthy of Dwell. That's Dwell magazine, sort of high-end modern. So we have homes that look like this. Vermont from the beginning has really tried to differentiate themselves from the typical manufactured home style. That said, people who live in manufactured home communities, mobile home parks, and even on private land do like the long linear home. Many of the lots only accommodate, that type of home. So you got to build it that size. You got to meet the same footprint that was there. This is also the most cost-effective approach. If we can deliver this 14 by 70 home, 980 square feet to the outside of the envelope, 2-bedroom, 2-bath, we can deliver this cheaper than we could do a 2-box home, whether we're stacking those boxes or putting them side by side, because this home is completely done in the factory. It's ready to be moved in the afternoon after it's set. You can see that floor plan there. Using my mouse, we got nice sort of master suite here, side-by-side washer and dryer, nice bathroom, plenty of closet space throughout, as you can see, a dedicated mechanical room, nice kitchen, living, dining area, and then this sort of guest or kids bedroom and bathroom. This same footprint can accommodate a 3-bedroom, 1-bath. You can put two boxes together. Here you get that nice bigger open living space, additional office or bedroom over here. So this is that mobile home park with the 14 homes right on Otter Creek. Beautiful site. Just a little less than 1 mile from downtown Vergennes, on town water and town sewer. Last house or last community that is served by town water and town sewer. Great site. Beautiful homes. This is what we started with. We had kerosene and oil and propane contaminated soils. We had asbestos and lead throughout every home. Lot of remediation to just get this property back to square one, virgin land. We had a sewer line and water lines that had to be totally redone, electrical service, so forth. So instead we had all sorts of setback issues with this design. These were all homes that were probably second generation from the time the park opened back in the 50s. So most of these homes were installed a second home in the 70s. So there were a bunch of setback issues. And there was really very little green space available to the residents there. So we went with duplexes instead of single homes. And that's what you see here. This is 2 living units. So we have a 2-bedroom with the living space on the end here on this side. And then we have a bedroom on each end, open living space here. So we did 7 duplexes instead of 14 individual units on this site. You can see these under construction in the factory. This went really well, building 14 homes exactly the same, really streamlined things in the factory. In fact, they automated a lot of things as a result of this project. Unlike a typical modular factory where homes are moving down a rail and there are these literally sunken areas in the floor where the plumbers crawl in and end up, using PVC adhesive and putting together sewer pipes and running wiring and plumbing and so forth. These homes are lifted 6 feet in the air with these hydraulic jacks that all work in synchrony. And all the contractors can just stand right underneath these homes. They have 5 bays. Every home is built start to finish in that bay. They're about 100 foot deep and about 20 feet wide. So plenty of room to work around the house, get these hydraulic jacks in. they'll lift this home up and down a few times during the construction process. The final time, the trailer backs in underneath this home and they pull it away to the site. When we get to the site, cranes there, you can see the 4 picking points under this home. We've got a full frost-protected crawl space. In this case, they put the gravel over the plastic the day before the install because they knew it was going to be good weather, so it was protected. There is a crawl space hatch on the back side of each of these. And this is the finished product. And so this is a affordable housing community in that they're all rentals. There were 150 applicants for these 14 homes in Waltham, Vermont, to give you an idea of the demand for affordable housing. They're already planning additional communities, not only in Waltham, but the surrounding areas. And, you know, when I compare this affordable housing, you know, to a multifamily building with apartments in Vermont, you know, we're in around $300,000 per multifamily apartment for subsidy to get in another affordable unit in our state's portfolio, you know, and this is a $150,000 unit here, and it's fully zero energy as opposed to code level multifamily building. So there's a lot of benefits here. In addition, this site would not have accommodated a multifamily building. You know, nobody wanted a 3 or 4 story multifamily building here. This is a small residential community, a rural area of Vermont, and this is really well received there. And I'm just going to show you a little bit of data on this one. This is, you know, working with low-income tenants, any tenants, even our market rate custom homes with, you know, the engineer who pushed and, you know, was really the catalyst for a high-performance home, who was bought in from day one of the design process. Even those folks, there's a learning curve on how to optimize your home and operate it properly. It's the same thing as we get into, you know, with rental, getting the tenants, you know, up to speed on how to operate a home and optimize its performance. You know, make sure that the serve is not cooling while your heat pump's heating, for instance, or, you know, opening up windows because your home is too hot. All those things, you know, and we're just working through those. But you can see this earned a home energy rating index of 1. That was pretty much all the units there. Almost every single one of the Vermonts delivered to date was either in the negative or below 5. So that's great. That's our goal out there. You can see those little adhesive back anchors that just stick on the rubber membrane, and the aluminum racking goes right on that. Micro inverters behind each panel here, N-phase micro inverters. I mean, no inverter down in the mechanical space or outside. This has been working really well. Indoor Air Plus, so all the finishes inside are either no VOC or low VOC. Everything, all the sheet goods, the flooring has to be labeled for low levels of, and no added urea formaldehyde. Even the countertops there are specially labeled. Nice finishes, you know, very simple and clean, modern. Nice deep windowsills because of that 10-inch thick wall where we put a nice wooden windowsill, plenty of plants on those in everybody's houses. You can see the heat pump up here in the top left corner, just tucked in there in the main living space. You can't put a traditional dryer in a high performance home. We're going to move away from traditional dryers. We can't vent, you know, 250 cubic feet per minute of air for 50 minutes in an airtight house. You'd have to open up a window. Even in your typical home, 50 minutes, you're pulling in a ton of outside cold, dry air this time of year that you're going to have to heat up again. Makes no sense. So we put in ventless condensing dryers. So what you see on top here is a Whirlpool ventless dryer. The warm, humid air goes through the back of the drum down through a stainless steel heat exchanger in this compartment here. The water vapor condenses to droplets and is pumped right into the same washing machine drain. And that's how your clothes are dried. You're not depressurizing your home and creating a vacuum on it. Everything is aerodynamically decoupled from the indoor space that happens in that dryer. High efficiency matching front loading washing machine below. Here's our heat pump water heater, our serve. These are filter boxes over here. There's our total efficiency of our HVAC system. We got our heat pump over here with our inside air handling unit with heat exchanger, our outside compressor. We got our heat pump water heater, and then we have our serve. You can see the total efficiency of that whole system. This is our battery storage unit. We have lithium ion batteries down here. You can see 2 of the 4 2 kWh Sony batteries. This will keep the home operating for 8 hours under worst case conditions when the power is out. The solar can continue to charge this battery in a power outage as there is a transfer switch in the unit that shuts off all power going to the grid and ensures that your home basically islands is what they call it. But basically you're creating your own power to be used via your battery. So that 8 hours could be extended indefinitely if your solar panels are clear and it's sunny during your power outage. Under normal conditions, when say you're just running the heat pump, it's not freezing cold outside, this could last 24 hours. So that's a great backup system. It's really great security. It's particularly good for folks who may have health issues where they're on oxygen, or a power outage could be, you know, really concerning in regards to health and safety. So here are the 14 units. And just to break down the graph, we got kilowatt hours used per month over here. We have each unit aligned down here. So we have our consumption in blue. Our green is our production. You can see that nice consistent production of solar across all homes with all having 6,000 watt systems. And then we have our net consumption here. So you can see only 1 unit was less than 0 energy here based on their usage, all full occupancy. But in Vermont, we undersize the solar system because we get an additional 5 cents per kilowatt hour on top of getting the retail rate. So for our 6,000 kilowatt hours produced, which is what this ended up for the full year, these folks are going to get that 6,000 times 5 cents. So they get another $300 in energy cost covered. And so to just jump to the next slide, this was the average for the community in regards to their cost per month. And so the average monthly cost across all these units was $20. These are all from bills, but $15 of that is the service charge. So for the year, having just done it, it actually looks better than this. This is 9 months of data here, and I apologize for not having the full 12 months, which we just finished that back in December. It averaged under $5 a month per unit per month for this community, which is great. And I will tell you that we had a lot of opportunities to reduce energy usage across these units. These higher units, I will tell you, some of them have medical devices that are, you know, have to be there that use quite a bit of energy. We have some where they brought in energy inefficient freezers to store deer meat, for instance. There's just things that happen in rental housing. There are some unknowns as well in regards to some plug loads. So we have circuit level monitoring that tracks every circuit in the breaker panel. So we sort of know the general breakdown, which you can see here. You know, we've got our HVAC here, we've got our water heating, our lights and plug loads. So we can begin to really fine tune, you know, where we want to spend more of our energy. But what we found is real high levels of indoor air quality, which was our main goal, and real high levels of comfort. And these units are only costing about $5 in energy cost per month. And I will say that everybody there pays a fixed monthly rental cost for their home. Energy is included. So that's a real benefit to this affordable housing agency that manages these. They factored in higher energy costs per month than they experience. So it's a win-win for everybody. But you can see here, there are plenty of great studies out there that I encourage folks to look at. Some of them you can only spend 15 minutes with because they're very detailed scientific reports on indoor air quality measurements and cognitive impacts of high VOCs and CO2. But I will tell you that at 800 parts per million, Harvard and Syracuse and the, I think it was Sandia National Laboratory, they've all found that there are cognitive impairments at as low as 800 parts per million of VOC and CO2. Most of us are living with much higher levels than that, both in our office spaces and at home. We have a study, and I don't believe I have the data here, but we have a study where we used our own employees, 35 of our own employees' homes, and put a VOC and CO2 sensor in master bedrooms for a week. These homes had only exhaust-only ventilation on timers in some cases, some just on toggle switches. And we did every other night, bedroom door open, bedroom door closed. We were seeing levels exceeding 4,000 parts per million of CO2 that people were sleeping with all night. And that is a really harsh pollutant. CO2 is proven to be a really harsh pollutant. So when you wake up all groggy and in that stale, moist air in your bedroom, that's a sign of underventilation or condensation on your window, for instance, in the morning. That's a sign of an underventilated space, and basically, you're really waking up drunk on CO2. And what we're trying to do is prevent that. And we believe that there are going to be proven studies that show much higher levels of productivity at home, better health outcomes associated with this type of air quality, which you see here. You can see that we hardly had any times in this house, and this is over a period of time, 1 year where, September to September, where this house sat mostly below that 1,000 parts per million, which is our goal. That's the EPA's recommended level for office spaces and homes. And you can see how the SERV operates here. Here's the month of January 2017, master bedroom VOC levels. And you can see how it just stays. If it ever gets up close to there, if it exceeds this 1,000 parts per million, it just turns on ventilation and flushes those VOCs or that CO2 out. And what's great about the SERV software, so I monitor all of my homes remotely. The SERV unit has its own proprietary monitoring software that's integrated into the unit. So I have a dashboard. I've got 100 homes out there with the SERV in it. I have a dashboard which analyzes all those homes together. But each individual home, I can look at metrics like this that are telling me how these homes are performing. And again, I won't get into too much detail because I know I've taken already too much time.
No,
you can watch a great PowerPoint on these metrics on Build Equinox's website, where it really shows, how they're coming to these numbers and these charts and proving that we're seeing much better air quality in these homes and what that means, whether it's comparing it to other standards out there or you're looking at what your exposure is over a period of time. So not only applying it to houses, but we just set our first classroom in St. Albans, Vermont. This is a zero energy classroom, all the same characteristics that I've shared, solar plus storage, all electric, really great space. This is for pre-kindergarten class, 20 students, 4 teachers. I'm really excited about this. That is, everybody's seen all the trailers that they've placed out there at schools when schools need to expand. Well, those trailers aren't doing the students, teachers, or society any justice, and I really feel like there's an opportunity here for that. We have a large development, 14 to 18 units going planned in Randolph for home ownership of zero energy modular homes that Vermont will most likely be building here in the coming year. This is the factory. Our goal is that we're going to have a network of these zero energy modular pop-up factories across the country, built near areas of high housing demand, creating economic development. This factory, 25 full-time jobs created since they opened, 85 home delivered to date, and a lot of CO2 avoided as a result of the type of homes that they're delivering. But a great opportunity here. VEIC, my organization, is working on a ZEM manual right now, that will really make this a turnkey product, going over the operations, both launching and the operations of a ZEM factory. And we're actually going to be we are rolling out this program in Delaware right now. We hope to be doing it in Massachusetts and New York in the coming year as well. So with that, that's our final house. This is our model home in Burlington, Vermont. That was a footprint that allowed for a 14 by 35 foot home. You can imagine what was there before that. It was an RV. And we put in a home. This came in 2 boxes, both 35 feet on 1 trailer, the roof system, which is a loft. And then that first floor, which is a 1 bedroom, 1 bath, open living space, and fully net zero. Pretty unique home for a mobile home park, but something we think is going to be a great approach to utilizing these smaller lots in our mobile home parks. So anyway, thank you for your time. Happy to answer any questions. And again, appreciate everybody's interest in this topic.
Nicely done, Peter. Thank you.
Excellent. Wow. I have a question. Can I ask a question?
Yes, please,
Sure.
go ahead.
Oh, okay. First of all, that was fantastic.
Thanks.
Oh my gosh. Unfortunately, I'm in Texas, and I guess let me know if one of those pop-ups come down here.
Yeah, sure.
As far as the modules you were showing, the 1 mini split in the central area, do you still get even temperatures in those bar bedrooms, or do you have other outlets there?
Well, some of our homes are a little bit larger, and we have some homeowners that we did install a very small cold climate heat pump in the master bedroom, for instance. So that we do have a couple of homes with multiple heads to ensure higher levels of comfort. Sometimes we have some elderly residents that were looking for like really cool in the summer and really hot in the winter. And we just wanted to make sure that we weren't taking any chances. And there are 6,000 BTU an hour, which is very small heat pumps now. So we can put a very small unit in that master bedroom, not overheat them or overcool them, and be able to take advantage of that unit. But 99% of our houses out there, no, not 99, but 90%, just have 1 head in the main living space. And we have the serve, which recirculates the air.
Okay.
And the strategy is we're really relying on thermodynamics here. In the heating season, the heat is going to move to cold. And we are not doing setbacks. So we don't bring the house down to 65 or 60 degrees during the day when people leave. If they leave, a lot of our residents are there full time. Either don't work, are retired, or work out of their home office. But we have a lot of residents who are around most of the day anyway. But most of our homes run at what I call a steady state. So they'll just sit at 70 degrees, 24/7 all winter long. So you're not bringing the houses up or down. And with that serve ventilation system recirculating the air continuously, it's just mixing that warm air from the main living space with the bedrooms and the bathroom, even the laundry area. So yes, what we find are high levels of sort of consistency across the space. We're going to see, sometimes we actually adjust houses because people think it's too warm in their bedrooms. That is, they're not used to having a 70-degree bedroom when the living room's 70 degrees. They like going into their bedroom, getting under their covers and having 65 degrees. So we've actually adjusted homes to make it cooler in the bedrooms in many situations because people are just not used to a warm bedroom.
Okay.
So you can definitely, both in the cooling season and the heating season, you can definitely achieve high levels of comfort throughout.
So there's serve. There's a ducted system, but it's for the serve, not for the heat.
Right. It's really. Yeah.
That's why I didn't. That's what I didn't understand. Thanks. Oh,
yeah. We have to get that ventilation air distributed to where we need it. We can't rely on an exhaust fan in the bathroom bringing fresh air into our master bedroom. It really doesn't work.
Yeah, and then you avoid the leaking of because I'm down in Texas, so air conditioning is bad. That's very important. But yeah, there's lots of leaks in the ducts, so that system avoids that because it's not the heat pump that has the ducts. It's just
right. And all of our ducts, for one, they're all air sealed with a product called mastic, which is like a thick paint. So every seam is sealed. Our ducts are also insulated, and our ducts are also inside the thermal envelope.
Right.
So inside the insulation, inside the air barrier, they're inside the house. So even if some of the air conditioning, for instance, got out of the duct, it's in the
Right.
house. Whereas a lot of homes have them up in the attic, down in the basement, in the exterior wall. When they leak, most likely it's going to go to the outside.
Right. Which is the way it is here. And so if you are doing your bedroom at a separate temperature, do you need a separate unit for that? A separate mini split unit or
No.
not?
If you want it cooler, and like for instance, let's talk about the cooling season as you're in Texas. So if you wanted your bedroom cooler, we would actually increase airflows to your space via the ventilation system. That's
Okay.
bringing in more cool dehumidified air. If you wanted it warmer, we would reduce airflows. We're always going to have enough airflow for indoor air quality. Our higher airflows that we achieve or that we design for are really just to move more conditioned air, more dehumidified cool air, or more heating air.
Okay.
We could have much lower flows if we were just dealing with air quality.
Okay.
Yep.
The serve sounds amazing. I mean, that's obviously the key. That
It
serve
is.
amazing. That's
Yeah, it's a great piece of equipment. I think we're going to see the ventilation industry is going to change. And the new version 2 serve, which there's a nice webinar on it, is even more innovative. And they're going to have better metrics. You know, the way Ty Newell, he was a professor at the University of Illinois and really was the mind behind the engineering of this unit. You know, he sees the serve as being able to respond to all different types of homeowner resident needs. So some people might need different things than other people based on various health issues. And he really sees these ventilation units as like a home management system. He doesn't think that you just dump a bunch of fresh air in and you should expect everyone's going to get what they need.
Yeah.
So his metrics, I showed some of that, are about really evaluating, are we getting this person what they need versus this other person who has a different need?
Yeah.
Yeah.
Thank you very much.
Sure.
I have a question. Firstly, fantastic concept and cause, and really wonderful what you guys are doing. Aside from the sort of issues with the heat pump, perhaps having issues at extreme temperatures, have you had any other ongoing maintenance issues with any aspect of the unit, whether it's cracks or any other mechanical or structural issues on
Yeah.
a long-term basis?
So structurally, no issues. These are overbuilt. They're really built for the delivery and the set. And so if they can take that, they can take sitting on a well-set, well-designed foundation. So I'll just say in regards to structural, great. Cracks in sheetrock have reduced them over time. They were never much because from the very beginning, we were using 5/8 inch sheetrock, gluing everything. In fact, some of the issues that we saw occur were an issue associated with homes. You know, they dry out in the winter and everything kind of shrinks, and then they grow in the summertime when the humidity goes up. And these homes were so structurally sound and so well built and so well tied together. We had a structural engineer come out who was looking at a seam where the vertical wall met the ceiling, and the sheetrock was opening up, you know, 1/8 of an inch in the wintertime, and then it was closing up in the summertime. And it was just like, what's going on here? Are we having moisture issues? It just ended up that was just everything, that framing lumber, everything was drying out. Just that little bit, but there was no flexibility in regards to the systems in the house. So really, his takeaway was they're really overbuilt and everything is just too well built, too well tied together in regards to everything being glued together and so forth. We haven't seen that since we changed the attachment detail of the roof to the wall system when we went with a SIP instead of we had TJIs before that. And now we haven't seen that anymore. So that was an issue that I think that we solved. It wasn't a structural issue. It wasn't a durability issue. It was really just an aesthetic issue in regards to that seam opening up seasonally. In regards to how the homes are attached to the ground, I would love to reduce the cost of that. So we've done a number of houses on auger-driven piers, if you're familiar with those. A couple of names out there would be Goliath or Techno Metal Posts. Those are really cool, no excavation. You're literally just drilling in, a frost-protected corkscrew with a pin that comes out of the ground and a little stainless steel L bracket. And your home sets down in that L bracket and you lag it in, and you know, on a 70-foot home, you need one every 9 feet. And, you know, it's 1/3 the cost of doing one of those full crawl spaces. We lay plastic on the ground, cover it with gravel. We do a little skirting detail about 8 inches all the way around the edge. And I'd love to continue testing that. The problem with that is you don't have great access under the home if you ever have any issues. And, you know, everything's exposed to ambient conditions then, right? You don't have this tempered crawl space that never gets below 35 degrees. When it's negative 27 degrees, at some point that space is going to be negative 27 degrees. But that last home that I just showed, that cottage, we weren't allowed to excavate in that park. We had to do the auger-driven piers because there were so many electrical lines and water lines and sewer lines right where we would need to put a crawl space in. We actually had to have DigSafe identify where we could put those auger-driven piers in to set that house. Right. And that's how a lot of the mobile home parks were laid out, because all they were doing was backing homes in on a trailer. They didn't care where any of the all the infrastructure was. So again, as far as other issues, you know, the serve, great unit. I am super happy with it. That said, it's a small startup. You know, we've definitely bought and installed most of their units. I think they have about 160 units out there, to give you an idea of how new they are, of which I probably have 100 of them in Vermont. So, you know, I think they're 100% committed. I think their business and their product line's only going to grow. But it is a small startup, and, you know, we're the early adopters there, and there's been a lot of back and forth. Fortunately, and I'm going to suggest this to everybody on this webinar, monitoring is so valuable. The fact that I'm able to watch the serve every minute and what it's doing, every circuit, the indoor air quality, the relative humidity, the temperatures, I can quickly identify an issue before it's even an issue at the household, you know. And a lot of the things now, and we're going to see this in more and more technologies, serve can actually get on that serve unit and they can operate it over the air, they call it, via the internet. And they are able to troubleshoot and often fix any type of serve issue remotely and not even have to go out on site. They're starting to do that with heat pump water heaters. You know, they can do that with routers now, right? You have an internet problem, you can call up Comcast or Xfinity, and they'll actually get on and start futzing with your router. It's that same idea, over-the-air service. And I think that there's a real opportunity there, both troubleshooting things and identifying issues via monitoring, but also being able to fix things remotely.
Right. And just finally, what if there's damage to the sheetrock inside or a section of the roof, like a tree falls? Are you able to repair it without compromising the insulation aspects of the house? And are you able to, you know, replace a section of the roof, or, I mean,
yep.
What does that entail?
You can pretty much fix anything, right? And there have been no shortage of deliveries where, you know, the homeowner had promised that they were going to cut this tree down and that tree, and the home's coming in and, you know, runs into this branch or that, or we've had a few trailers go off the side of the road. And what I would say is everything definitely is accessible and can be fixed, whether it's a SIP, a structural insulated roof panel. The solar panels are not installed until on site. So all the racking, the inverters, everything's all set. Literally, the panels come to the site separately with the electrician, and they go up on the roof that same day and put all the solar panels on. So just so they don't get damaged. But yeah, down the road, anything could be fixed. This is a very simple structure. It's wood framed, and anything that breaks could be replaced very easily. Yeah.
Thanks.
Sure.
I have a question. How much of this technology is available for bigger homes?
Well,
Modulars, but still bigger.
Yep, all of it. I will just tell you that the first home I installed a serve in, was a 2,000 square foot, 25 by 40, 2-story home, actually with a third story because it had insulated slopes, a third story that was finished as well as just like an open play space. That was on a frost protected slab. It was a passive house. And they put the serve up in that finished third story and ducted down to the spaces. And all that home has is the serve, an inline duct heater, and a wood stove. And that house is like my best performer out there. It relies almost exclusively on the serve for all conditioning and indoor air quality needs. They use the wood stove under harsh conditions. And they've got a large solar array on their single, 12-12 pitch, perfectly south-oriented roof. But I could mention another 15, 20 homes just like that. Very smart, well-designed homes that rely on just a heat recovery ventilation system and a single heat pump head. And those heat pump heads, they're as small as 6,000 BTU output all the way up to 18. And that 18,000 BTU an hour, I don't think I have a home with one of those in it because they're oversized for the loads we're achieving with these characteristics in a home. So after I did that Habitat passive house, that was about a 1,200 square foot home on a full basement. We did another 4 modular homes that were larger with those same systems. That same envelope, in that case, it was a 2x6 wall, dense packed with cellulose, with 2 to 3 layers, depending on the project, 2 to 3 layers of foil-faced polyisocyanurate on the exterior. And then that was the approach to that modular manufacturer's assembly. And that worked great. It's just more expensive. And for me, I try to stay away from foam as much as I can because I don't think that it's necessary. In most applications that are above grade. I think foam has its place in below grade applications, under slabs, around foundations, but I try to minimize it when I can. If I can use rock wool or foam glass or cellulose or even blown in fiberglass, the embodied energy in that insulation is less. So, you're basically less of a payback in regards to what the environmental cost of that is initially. If that makes sense, not to get off track, but so yeah, this technology is applicable to much bigger homes. The serve comes in one size, and the flows can be changed based on the fan output. They're variable output.
Would Vermont would they do all of the engineering and the with respect to bringing all this technology together in a bigger home?
They have, yeah. They've done a number of 4-box homes. They've done 2, 3, 4-box homes. Absolutely, they have some nice bigger custom homes. Now, granted, they're all modest size. When I say a big 4-box home, I'm not sure they've broken 2,000 square feet yet with a home, but
that's the size I'm talking about.
Yeah. So when in regards to what you would expect from any modular manufacturer, let alone Vermont, there are limitations. What a person like myself or John or Gio can bring to a project is different than what you should expect from a modular manufacturer. They're going to have a very good in-house designer, and you can get a good design that's going to work to meet your expectations, and it's going to be buildable, and they're going to be able to do that. But once you get into duct design and really looking at your thermal zones and making sure you're meeting comfort levels, and engineering the percentage of glazing that you might want to have on the south versus the northeast and west, that's where it's good to have a passive house consultant or at least an energy rater involved. That can help you assess the design and optimize it. Build Equinox does help with duct design. but they're not going to do what's called a manual D for you and really nail like exactly what the size ducts are, what elbows you should have where you need dampers, the type of diffusers. There are a bunch of national outfits where you can send them your floor plans, send them the equipment such as the serve, and they'll do the duct design for $500, which is a steal for the value of getting the exact flows that you want at each of those grills without, heroic efforts when you finally finish the house.
Great. Thank you.
Sure.
I have a question about your windows.
Yep.
Are they all opening windows?
For the most part. I mean, it depends on the design. We don't want to overglaze homes, and we also don't want to install a bunch of operable windows when they're redundant, right? So if you really only need, say you have 6 windows going across your south living room, maybe you only need 3 of those to open, right? And the other 3 that are like the opposing windows could be fixed. The fixed are certainly going to perform better with regards to air tightness. And they're also going to have more glass because you don't have that built-in sash plus frame. You just have the glass built into the frame. It really is customer preference. We try to provide guidance in regards to that. The fixed panes are far less expensive as well, so cost can be contained by removing operable windows where they're not needed. But anybody could live in these homes without ever opening up their windows. And I will tell you, a lot of people don't in Vermont. We don't have a lot of those perfect days when you're like opening everything up, But that said, you can open everything up in these homes, and we really want people to be able to use cross ventilation, passively cool their home, and really take advantage of opening up their windows. So we definitely wouldn't, we never recommend folks putting in a bunch of fixed pane windows and remove that opportunity of opening them up and really allowing the fresh air in directly as opposed to through the ventilation system. So yeah, there's a balance, but you got to meet egress in all the bedrooms, and you want to make sure that people can cool off their home with outside air without any of the HVAC systems on as well. So we're thoughtful of that.
But I'm just trying to understand the importance, since you're net zero anyway, and you have cooling and heating heat pumps.
Yeah.
You have the serve.
Right.
So, other than egress, what do you need opening windows?
Yeah, you don't. And you're absolutely right. But what I would say is, at least even in Vermont, where, we have a handful of those perfect days where you do want everything opened up. People still like to open up their windows, get their casement windows wide open, catch that prevailing breeze, flush things out. So in that perspective, these operable windows are great. They're so tight, lifetime warranty on the hardware, so you don't have to worry about things breaking and them not getting replaced. But you're right, they say this with passive houses as well. The serve is so smart that it passively cools. So it's checking the temperature from the outside every minute. And if that temperature outside goes below, your set point and you're in there actively cooling, it'll just start bringing in fresh air and turn off the heat pump. So it's just bringing in fresh air to passively cool your home, which is what you would want to do with night flushing. But that's when you open up your windows and you got to go over to your ventilation system and turn it on into exhaust only mode. And the serve does that for you. It's that smart. So, you don't have to have operable windows, but it's something that people want.
A couple of questions about your barriers. You said that there's a sprayed on barrier to your sheetrock. Is that on the side facing the interior of the wall or towards the room?
Yeah, it's just the latex primer. That's all it is. It's just paint.
Which side of the sheetrock is it on?
On the finished side, interior.
Okay.
Yep. It's just, instead of doing a typical latex primer, we do what's called a vapor barrier primer. It's like it has a perm rating of about 1, so it really almost eliminates any vapor drive into the wall assembly. that one coat of vapor barrier primer goes on, and then we do 2 finished coats of latex. What a typical modular manufacturer does is they'll do 2 coats of primer and they send the home to you, because they're anticipating a lot of sheetrock cracks, and they're also anticipating a lot of work to put that house together in the field. And typically the general contractor who manages the set and the finishing of the home will have the house painted when they're done. So it's different. Vermont does the primer coat and 2 finish coats, because when they deliver it, typically there are hardly any sheetrock cracks, and that's the finished product people are moving in.
Your exterior zip system, taped zip system, I've heard some skepticism about the longevity of the tape and those kind of things. Do you have concerns, or what do you think the longevity is?
I think it'll be a very durable long-term product. There has been some great third-party testing of all these different tapes out there. You know, one's from Europe, Scandinavia, Siga tape, and there are a number of them that are great. Vapor permeable, really sticky. But what I would say is time and time again, I've seen that zip tape outperform all the other tapes, particularly, and that's on just typical OSB or CDX sheathing. When you apply it to the zip system, which it's designed to stick the best to, it's incredible. You can't even get it off. We've gone back to a bunch of homes where we put that zip tape on years ago when it first came out, and the stuff's not budging. It's not moving. So, you know, I have a lot of confidence in it. Could we get to a better system? There are some liquid applied air barriers where you sheathe the house completely in just OSB or CDX, and then they have this roll-on or spray-on vapor permeable a barrier. So it's like one big piece of zip tape that you put over the whole house. So there are different approaches. I'm happy with the zip product. It works really well for our application, and you know, I'll keep my fingers crossed that it continues to work as well as it has to date.
Thank you.
Sure.
Are your modules shipped with the siding in place?
Yep. As much siding. If it's a single box home, everything's done. Literally, the house looks like you could move into it. If it's a 2-box home, typically the siding is almost 90% complete. There's a little bit of, like, you know, depending on the detail, there's places where they'll integrate the siding together. But yeah, siding's typically complete. I'd love it if we avoided vinyl, but it is very low maintenance. The high grade vinyl is very durable. It requires no maintenance, no painting every 5 years. Most of our homeowners are, you know, looking for a no maintenance exterior finish. So we do a combination of vinyl, metal. We've done some in all wood. We've done some in all metal. We've done some in all vinyl. But vinyl and metal is the best product in regards to exterior durability. My hope is that we're moving into a more environmentally preferable product. We're working right now with the Healthy Building Network, just starting to evaluate all of the materials, everything down to the screws that go into our zero energy modular product to really optimize looking at price, environmental impact, and durability. And, you know, siding is just one of those things. It's always been difficult. And we're looking to really reduce maintenance costs for folks, increase durability the best we can. The other thing about vinyl is it's naturally vented behind the product. So we don't need to put a vented drainage plane behind there, either like a cedar breather product or strapping. And that reduces cost and improves performance. So same with the metal. The metal just goes on there. We lag it in, super durable, lasts forever, and it's vented. So you know you're getting that nice air movement behind.
Question about the solar panels. I mean, where are they manufactured, and are you always looking around for the most efficient ones on the market?
Yeah, I do leave that up to our manufacturers. I make recommendations, and there are all sorts of new and improved products out there. But I will tell you, it's less where manufacturers are leapfrogging each other. There's so many advancements that it's even hard to know who's ahead of who. So, there's new panels that are the same 3x5. They're actually a little bit bigger than that, but that are putting out 360 watts per panel instead of 260 watts per panel, which is where we were 3 years ago. So, but everybody's doing that. The big differences are honestly in regards to aesthetics. All black panels, or there's different silicone aesthetics, and for us, people can't even see that we have solar panels on the roof, unfortunately, because it's on a more or less flat roof. But I'm thinking that, so we use Solar World panels to answer your question, and we change the output per panel based on cost. So right now, 300s and 320s are pretty much the go-to. A little less modules with a system than 2 years ago. It was a lot of 260s and 280s, and we had more modules per installation. So, but we've pretty much exclusively stuck with the N-phase microinverters. We like the performance of those in regards to, those are really the best of the best in regards to maximizing output of a system. We're also on a flat roof, so a leaf could fall on a panel, or you could have snow on part of a panel and not on another panel, just shading and so forth. We want to make sure that every panel is running individually, so we're always maximizing output of that system in addition to the output of each individual panel based on the solar radiation. But not to get into too many details, but that the system we're using is working really well. There are actually adhesive back rollout flexible panels that were on the market years ago. In fact, when we were first putting solar on standing seam roofs, we were using this unisolar product that literally was like, it was like ice and water shield, but it was a solar panel, adhesive back. You peeled off the paper and you stuck it in between the standing seam on a roof. That company, that manufacturer, didn't survive. Lower output per square foot for that type of solar, but it sure went on quickly and easily. What they found is in some applications, particularly on like Vermont steeper standing seam roofs, particularly darker ones, they got so hot that those unisolar panels would slide down in the summer on the hottest days, and the adhesive would re-stick when it got cool. But there are new products out. Miasol is one company, and I do think that there's an opportunity potentially with our product to just do the adhesive back sort of amorphous solar installation instead of all the aluminum racking and all the fixed, larger, simple, typical modules. So we may transition in that direction as that product is more proven. I like being on the bleeding edge, but right now, honestly, I would try that, but the price per watt is still higher than the system we're doing with all the racking. It's just not competitive yet from a price standpoint. So we have plenty of surface area to use it, even though it's still lower wattage per square foot. We have plenty of roof space for the amount of output we need. Does that answer your question?
No, thank you. Yeah.
Okay, sure.
How did you settle on the batteries that you're using?
Well, we haven't. The Sonnen battery is great. I'd say there's two players in the market right now that have proven their product, and that would be Sonnen and Tesla. And actually, we have a deal right now with our local utility. When the Tesla Powerwall 2 is available, that's kind of like the Model 3 at this time, we're going to be putting a Powerwall 2 in every home. And that's just going to come with each home as part of the package. And the reason we're doing that is our utility only charges $1,500 for the battery and the installation. So they install it, and then you have the resiliency and the backup power there, and the utility has access to that battery to discharge it a few times a month when they think they're going to hit their monthly peak. So we'll be using Powerwall 2s, but honestly, we have two new model homes, one that's going to be touring around Vermont called our Zem on Tour. That's 40 feet by 14 feet. That's going to have another Sonnen battery in it. And we have a factory model in Wilder, Vermont, where the Vermont factory is. They're about to roll out a new factory model there any day with the new serve unit and another Sonnen battery in it. So we're still using the Sonnen batteries because the Powerwall 2s are not available yet. They're out there, but we just can't seem to get them. There's Pika Energy out of Maine. They have what appears to be a really elegant and robust system, but I haven't tried it. I can't speak to its reliability yet, but that's locally made. I'm excited about that product, and there are others.
Two completely different questions. Are you able to add two units together and break the wall in between and still have it insulated?
Like two modular units?
Yeah.
Yeah.
To create a 28 by whatever, 40 foot.
Yeah. I'll just jump. Let me just share my screen real quick. Sorry, just take a second.
You showed us one of those.
Yeah, I'm going to just open up the.
Yeah, good.
There you go. Something like that.
We're not getting it yet.
Is that what you mean? So we have two. Basically, we just have a single 2x4 wall.
Peter,
You're not showing it.
Not showing.
Oh, it's not showing up?
There you go.
Hold on. Hold on. Oh. There we go.
Yeah.
Sorry. I'm just going to pop that up. Okay, how's that look? So you can see the two common walls here, and then we just have some openings in that common wall that provide this larger living space here, connections into the bedrooms. Is that what you were asking?
Yeah. So you built them and then you break the wall in between, do you?
You don't even break it. It's delivered with a single 2x4 wall here, and these openings exist. We do not need, those openings exist, but imagine there's a SIP roof system over this, and there's a full, 10-inch TJI floor system here too, right? So those openings are just there in both boxes at the factory, and they're delivered that way.
Okay.
Yep. So we don't break anything down when it gets to the site. Depending on the weather, and you cannot travel down the road delivering a home if you have to use your windshield wipers. You also can't deliver a home a day before a holiday or a day after a holiday. And there are many times that you can't deliver a home because the sheriffs aren't available, or you can't get a truck. If there were wet roads, you may shrink wrap your homes to protect it. You may cover these openings with some plywood just to get it to the site, so no road spray is getting up and impacting the finishes with dirty water.
Right.
Could you put two modules on top of these two?
You could, absolutely. I mean, we've done standard colonials. I would show you some other designs, but I'll tell you, whenever I tried to open something else, it messed up my internet here, slowed it down enough that the feed with this webinar was compromised. So, but yes, we've done standard 12.5-foot boxes by 40 feet, two on the first floor, 1,000 square feet, 25 by 40, and then two more on top, and then either, a shed flat roof, kind of a modern design, or just have a bunch of trusses delivered to the site, pop them down on the roof, and, you're good to go with a nice typical colonial with a 10-12 pitch roof.
In those scenarios, can you customize the siding based on customer preference? Absolutely.
You name the siding, they've utilized it and integrated it into designs. That's the easy part. It could be anything. So absolutely. We've done fiber cement panels, metal, as I said, all different types of metal, everything from like a standing seam to a corrugated to all different types of wood, both vertical and horizontal clapboards, and various vinyl.
I have a question about the economics of what you're talking about, cost of ownership and you know, in the low cost housing market as well.
Yep.
The example you gave were rentals, but people who bought these homes,
Yep.
have any of them had issues getting loans, or do the banks actually incorporate the cash flows from utilities and then offset it with the higher cost? I mean, do they actually buy into, you know, do the banks actually factor in a zero cost, zero utility cost into their equation when they calculate the debt to income ratios?
Yeah, okay. So it depends where you are. So, you know, I'm not sure where you all are from, but Carol, for instance, in Texas, may not have as easy a time as Carol in Vermont would have. Here, we have a nice network of appraisers that are competent, and that's like the lingo in the appraisal world for they're actually certified to evaluate sustainable buildings. So they bring this competency to the lender. So if you have a zero energy home, anything better than code, to be perfectly honest, but let's just say it's the zero energy home, you can go to your lender and you can say, I'm building you know, a home that exceeds code, and you need to hire a appraiser that's competent in sustainable buildings, and it's actually federally mandated that they do. And we actually have a letter that we hand to every home buyer that participates in our residential new construction program, whether they're building zero energy or they're building to Energy Star, or we have actually our own Efficiency Vermont certified standard. They get a letter, and we fill out what's called the Green and Energy Efficient Addendum. That is an addendum which literally defines the value that an appraiser puts on their evaluation. So you put in your home energy rating index, you put in the estimated annual energy cost, the savings when compared to code home, you put in the actual PV size and the kilowatt hour output anticipated. We use NREL's PV watts tool that will then input that. And there's actually a calculation that literally puts a fixed black and white number on how much that solar is worth on your appraisal. And so all those things come together. The appraiser is able to, instead of just being like, hey, I can only value the desirability of your neighborhood and the number of bedrooms and bathrooms and the square footage of your home. Now they have a definitive tool that they can fill out and say, your home's worth this much more because it saves this much energy a year and your solar produces this much. So you can fill out the Green and Energy Efficient Addendum with your energy rater if your home is certified by a energy rater with the Energy Star Home Program, or a passive house consultant, or a LEED accredited event professional. They could all help you with that. You bring that to your appraiser if you don't have an appraiser that's competent in sustainable buildings, and you could still incorporate that. It's federally mandated. But if you have appraisers with that competency, it makes it that much easier. They're already aware of it. They've been trained. They've gone through formal classes. They've taken an exam, and they're certified to actually evaluate those types of buildings. A residential appraiser who's not trained in sustainable buildings, they're as qualified to evaluate a commercial building as they are a sustainable building. I mean, it's amazing how little comprehension most appraisers have of the things we've been talking about today. They just don't have the training unless they've delved into this on their own outside of their industry and their work, and they're just interested in it on their own. They typically won't understand the value of PV, the value of better insulation, air tightness, heat recovery, ventilation. They won't know those terms or understand the value. Does that help?
Yep. No, thank you.
I have one more question.
Sure.
Back to the serve. which is monitoring everything, does the serve have the capacity to control the humidity independently? Because the nights can get cool here, but it's still too humid to let in outdoor air as is.
Yep.
can
It does measure the relative humidity, but it doesn't manage humidity. So you can't say like, I want my humidity to be X. But when you're recirculating your air and only ventilating, bringing in that hot, humid air from outside, only when you need it, it will automatically meet your dehumidification demands in the house. So what happens in a home that's leaky is you're getting a lot of that warm, humid air coming in when you don't want it, and you're continually trying to dehumidify that air and cool it. The serve is really efficient in regards to how it's managing that indoor air. It's recirculating the air most of the time, so it just continues to dehumidify that already dehumidified and cooled air, if that makes sense. So, and in our system, you couple that with a heat pump as well, and those couldn't be better at cooling or dehumidifying. They're actually the most efficient devices you can get on the market in regards to pulling water out of the air and cooling the air. So you put those two together, and you can expect very low humidity in your home when compared to outside conditions, and you'll find higher levels of comfort than you would with that big, ducted air, typical air conditioned system. Those are typically very good at cooling, but they're typically oversized and don't do a good job at dehumidification. So you get like that cool, damp air. You'll find the opposite here, where you get a great job done with the dehumidification and less of just that cooling only effect.
Great. Perfect. Thanks.
Peter, if I wanted to pursue some of the ideas that you're talking about here, who would I contact to actually look at the house design that I'm thinking of?
Yep.
Where
are you,
Ron? In New York State, Upper New York State, the Adirondacks, close to Lake George.
Upstate.
Brant Lake, to be specific.
Yeah, sure. Okay, not far from here. Well, we could chat. I will tell you that we were just funded by NYSERDA to do a feasibility study on rolling out the ZEM product and program in New York, but really with a focus on upstate New York. Vermont, if we move forward, we're hoping to do some pilot homes in upstate New York with Vermont, which is what we're planning to do in Massachusetts as well, with the idea of ideally building a factory in upstate New York and Massachusetts after, sort of rolling things out, delivering these remotely. But you could definitely talk with Vermont about your design. They'd be great. Amanda is their in-house designer. Steve Davis is the owner and is really hands-on in regards to overall operations and discussing projects like yours. So you'd probably be in contact with the two of them. You'll start off with Kristen Connors, who's the office manager, or Ashley, who's in sort of sales at Vermont. But you'll end up with Steve and Amanda discussing the more detailed aspects of your project and how they feel about it.
Great.
So I wouldn't hesitate to ring them and set up a time to either meet in person, come over. And if you did, I'd be happy to give you a tour of existing homes, certainly meet at the factory as well. I spend at least a half a day there a week. So, and we have a lot of projects, right across Lake Champlain, not far from you, that I could show you. This McKnight Lane, probably be, I don't know if it's an hour and a half for you to get there, if that.
Great. Okay. Thank you.
Sure.
Peter, the rental units that went through the cold snap and the heat pumps went off at 18 and didn't come back on until the next day. How low did the interior temperature get to?
We had, well, I only monitor, I only had 4, there's a fairly new development there. And I had 4 of the units monitored there, and none of those units went below 60 degrees. And I know that 2 of those units, at least, their heat pump shut off in the middle of the night. So there's very little drift, even under those really harsh conditions, with occupants inside. And I'll tell you, interestingly enough, the property manager there, because that's 13 low-income rental units, the property manager showed up first thing in the morning, and they plugged in, these little 1,500-watt space heaters into a couple of those homes, and those homes were up at 80 degrees about 2 hours later. It was amazing. So it didn't take much to crank those right up and get those cooking again, even though the heat pumps didn't come on till that afternoon. So, I talk about a backup system and everything for these. Your average homeowner could have, a very small little plug-in heater that's in a closet and they just pull out under a circumstance like this. But yeah, very little drift. Historically, we've certainly had our fair share of power outages that have occurred, not as cold, but definitely in the teens and single digits. We had a snap 2 Decembers ago where we had several Vermonts in the Northeast Kingdom of Vermont that were sitting in the teens. It was a Saturday night through a Thursday morning, and none of those homes went below 55, and that was without any heat. That was just people body heat inside and passive solar gains during the day. So just an indication, if these homes were, my passive houses, they have 12% glazing to floor area on the south, 2% glazing to floor area on the northeast and west, and we have high solar heat gain coefficient on the south, so 50% of the sun's energy can get in those windows and heat up that interior space. Those homes, I have a home in Norwich, Vermont. It was stick built. Oh, I'm sorry, it wasn't stick built. It was actually a Benson wood home, but a real modified Benson wood home. It was more stick built than it was a panelization. That house has no active heating system. And I've watched that house for 3 winters straight. And that house fluctuates between like 60 degrees and 75 degrees with no heating system. It's really cool. And that's just good passive solar heat gain. And that's a seasonal resident, so they're not even at the house. They have a wood stove, a cook wood stove in the main living space. And they have electric radiant floor mats in 2 bathrooms. They had those on the first winter because they were sort of nervous about it. And then they turned them off just to test it out. And that home never gets close to dropping below 50 degrees. And that's with nothing. So that's with really good passive solar gains. It's a passive house. So, German windows and doors, and they must have an R50 wall assembly, R80 roof, super duper house. But it's possible. And our houses, they'll drift a little bit more, but they still have that resilience where they can sit for a long period of time, and you're never going to get to a point where you're worrying about them freezing.
Hey, Peter, I have some geeky questions here.
Sure.
Just so that adhesive PV rack is rated for 120 mile an hour, 110?
I'd have to go back and look at the specs. It was rated at comparable to if we actually were drilling into that rubber membrane and fixing it with the actual anchors. So that was, yeah.
That means the adhesive, since it's attaching, I'm sure pretty well to the membrane, that means the membrane has to be adhesed down equally as well, correct?
Yep, exactly.
Yeah. And that, okay, so that's one geeky question. The other one is, I'm of course also in love with heat pumps. Have you used Daikin much? I
have never used a Daikin heat pump on a project. They are great. Their Quaternity line, I think they have a great product, and they have some other really cool, the Daikin Altherma. It has a lot of potential if they bring their latest versions here to the US in regards to air to water. They may be the first ones to really break into that, what is an unmet market right now, where you can have radiant panels, off of there's Daikin's great company. I mean, I'll tell you, Fujitsu, They're RLS 3YH, Wi-Fi enabled, super cold climate heat pump. Arguably as good, if not better, than the Mitsubishi MSZ MUZ FH series. That's what we use in the Vermont model, and I've used in most of my other projects. Not because we've used Fujitsu's in projects. Sanyo, which is now Panasonic, they're coming out with their cold climate line. So we're just going to see more and more of those.
Oh yeah.
It's an untapped market, for all these other players that are just getting into it.
It sure is. And they're coming in, their price point is starting to be equal to, or even in some cases below, the more conventional hydrotherm approach. So I agree with you. Here's my last geeky question. You were saying that you got your price, and I may be stating this incorrectly, so correct me if I am. You were producing rental units at 150,000 per unit compared to 300,000 per unit for a typical mobile home.
No, that was for a multifamily apartment. So when one of our affordable housing organizations goes out and they apply to our Vermont Housing and Conservation Board and our Housing Finance Agency for funding to do a big multifamily.
Yeah.
Our average cost is over $300,000 per unit to do that. Now that is here nor there, but that's how much it costs. There's a lot of permitting, all the soft costs with engineering and architecture, and then of course building these things. And most of those units, while we just finished our first passive house multifamily, we've had some close to zero energy units. There's very few of those, but they're out there. But most of them are built just beyond code, right?
Right.
So that's at $300,000 per unit. So all I was saying was, not many people come to Vermont to live in apartments. And so we have a lot of people who are looking to have their own four walls and roof, live in a rural setting, but they need to be in low income rental. And so all I'm saying is we have, 9,000 mobile home park lots in our state, of which, we have hundreds of vacant lots or abandoned homes in these communities that we really need to invest in to rebuild, move from stigmatized mobile home parks to actually thriving communities with good homes. And so all I was saying is for $150,000, we can put a 3-bedroom, zero energy home on that lot and charge the same rent and do it at half the cost of an apartment.
Yeah. So I'm excited to extrapolate and think, well, I know nobody comes to, well, not nobody, but few people come to Vermont to live in apartments, but
they come to live in mobile home parks.
Well, they do come to live, independently, but
yes, exactly.
There is a large market segment outside of Vermont that would like to live in denser configurations. So if you can build, discrete units at 150,000, think if you were doing a multi-unit, if you stack these up, say, and started making 10, 12, and 15 unit, do you think you would be able to maintain that 150,000 or better? Or maybe you're already going to show me that.
Well, I'll tell you that, let's just say, that done, delivered, people moving in, solar on the roof, we're at that, $150 a square foot finish. So, and that's a lot of expensive space because we're talking about a 980 square foot home, right? So if you went to a bigger home, you have a lot more cheaper space in that home, bigger living room, bigger bedrooms, maybe a third bedroom instead of only 2 bedrooms. So that price per square foot comes down.
I'm thinking if you up the number of units.
It's a good question. Right now, if you worked with a modular manufacturer that's pushing out a box or boxes a day, you can start working with economies of scale and start bringing down cost with a volume purchase. But at the end of the day, a small manufacturer that's doing a home per week or a box per week, there's not much room for economies of scale to go anywhere below what they're already doing. that's not to say that we can't get there. But you know, what they're hitting for a price point right now is very competitive. Vermont is a social enterprise, so you know, honestly, their houses could be a lot cheaper if they didn't provide the benefits and the paid vacation and all the things that they do for their employees. They also work at a scale where they never have to lay anybody off. You know, a lot of these modular manufacturers, Titan Homes over in New York, they close most winters.
Yeah.
And lay everybody off, and they bring them back, or whoever comes back sometime in the spring when they start getting orders. So, you know, that is what it is. I'm not sure how much room there is. One thing I'll note is that Vermont is working with the Manufacturing Extension Center out of Vermont Technical College in Vermont right now. So they are literally overhauling all aspects of their business, from the office, front office, to the factory floor, to post-occupancy support for their homeowners and tenants. And I'm hoping out of that there are significant efficiencies that are gained in regards to this lean thinking methodology with you know, manufacturing. And in that, I'm not sure if the price will come down. I really don't feel like that the price has to come down. It's a very good price. I'm not.
I think the price is remarkable. And I was worried that if you stacked up 6 units, say, or
Yep.
anything that was below the requirement of an elevator, that it might move up. But you know, 300 is for a standard unit, or even a good standard unit in a higher density multi-unit configuration. That's pretty good actually for an efficient unit. So to have discrete units at 150, I just would like to say to my students, that is not just pretty good. That's unfreaking believable. It's a really, really good price point. And I'm really just asking, if you stack them up into a multi-unit, do you think that it would rise up towards 300 or stay more like maybe between 150 and 180? I mean, it's all conjecture, but that's the real focus of my question. Is that's an amazing starting point.
I see what you mean. Yep, I see what you mean. There have been some good examples. I would encourage everybody to look at the Bella, Bella 2 times, Bella project. That was done by a Monty Paulson's a passive house consultant. He was the real catalyst and the lead for that project. But that was a multifamily project that went up to a reservation off of British Columbia, and phenomenal, like a 5-plex. It was for healthcare workers, housing on a reservation for a small tribal nation up there. But that was a good example of what you could do small multifamily with modular. I mean, they're doing mid-rises out of modular out of Brooklyn right now, and there's definitely economies of scale, John, with regards to what you're saying. Absolutely. Not for Vermont, but for other manufacturers. Once you start to get into that volume, the repetitive nature of the same boxes stacked on top of each other, that's not Vermont's business, but I think that's a great business. Mm-hmm. And I'm hoping that in Vermont, particularly with our climate, that we start seeing more multifamily modular projects, and that our architects and our engineers and our developers early on are thinking that way, because there are too many buildings that are designed without thinking about modular. All they do now is think about panels out of Canada. That's the way they think it. And I think that there's a real opportunity to move to modular. I think
there's also there's another thing we haven't talked about, but you know, there is the whole waste stream aspect of these units, and then when you bring them together in a more dense configuration, you can start to have proper waste treatment instead of everybody having their own on-site waste treatment. There's a lot. It's a conversation, and we're also an aging population, and so people are looking to have less to maintain. So there is a market segment that wants to live in triplex, duplex, you know, dense neighborhoods where there's less to maintain. And you know, this concept in its let's face it, is still its very beginnings.
Yep.
Promises much bigger things. It's really it could be the answer to many social ills that are the result of bad building practices. So it's a really very exciting presentation.
Absolutely.
Yeah, I'm excited about it. We have just so many partners on this, and I just pulled up this screen just to show you. I mean, this is that Randolph development, really small lots, houses in close proximity, walk into town. You know, you can go to Randolph, and for $150,000, you can buy an old house. That's going to be quite a burden. You know, that's a classic low upfront cost, but all the maintenance you could ever want, and certainly the energy costs and the comfort issues and zero ventilation system and so forth. What we're hoping is to provide an alternative to that. There are a lot of places like that throughout New England where you can get a cheap house, but it's only cheap up front and it's real expensive for you in the long run. And what we're hoping is, you know, in village settings like this was already a permitted site that just was never developed. Randolph Area Community Development Corp acquired it, and now they're considering something like this, which I'm really excited about. Can
you zoom in? Peter, can you zoom in on that site plan? Or I don't know if that's possible, but
I can't zoom in on that.
No worries. No worries.
Yeah.
Anyway, that's cool. That's very
cool.
Just a quick question about the cost structure. I think you were starting to give that example. If you were to put 3 or 4 of these modules, these 980 square foot modules, for a 3,000 or 4,000 square foot house, is it reasonable to expect the cost per square foot to come down because you're not multiplying the number of kitchens or, you know, mechanics?
Yes. Yeah, definitely. There are definitely advantages there. Less expensive square footage, kitchens, bathrooms. You know, your house can get bigger and you're still going to only have, you know, 1 kitchen and 2 bathrooms, for instance. Everything gets less expensive as you make your living spaces and your bedrooms larger, or you add additional bedrooms, or you add a formal dining room. That's all very cheap space. You know, that's $100 a square foot, and the kitchen's you know, $200 a square foot kind of thing. Yeah.
Peter, did you say that the windows that you're using are triple pane?
Yep. Triple pane, but standard casement and awning. What you would find in a passive house project, you know, when you're talking about just a better window, would be a tilt and turn window that opens to the inside. You turn the lever, opens in, screens are on the outside. And then if you turn the lever up instead of down, it tilts in from the top, and then it's just open at the top about, you know, 6 inches. That's a tilt and turn window, very common in Europe. In fact, they're common in a lot of places. I was just down in Cozumel, Mexico, and every place I went to had tilt and turn windows. So, you know, it's just different style of window. I happen to like it. They do open to the inside. They're more expensive. That's the difference. And they're more expensive because they really do have better hardware. They're better windows. They're heavier. They're big, heavy windows. And they have much more frame area. When you look at a North American window, we have very little frames and very little sashes that are typically about 2.5 inches total. 4.5 inches is not uncommon for a tilt and turn window. So you just lose that transparent area, and you're paying more per square foot for that window. So it's like you're paying more for less glazing.
Okay.
I have a hard time with it. I love the tilt and turn, but you just lose glass.
But that's what you use in these modular, the modules that you're talking about, modular homes.
We use typical North American windows that are casements or awnings that open to the outside.
Oh, okay.
And those have the smaller frames, the smaller sashes, more glazing for a window.
You use that because it's cheaper?
It's cheaper, yep. More readily available. Actually, you know, there's just not a huge demand in North America still, even with the big passive house movement and the movement of high performance homes. for tilt and turn windows. So there's very few manufacturers, and you pay a premium.
Okay.
You know, we're paying $25 a square foot for our triple glaze R5 windows, and they work great. Lifetime warranty on the hardware. $1 a square foot for a tilt and turn window.
Okay. Great.
It's a lot.
Yeah.
More than twice the cost. So we just can't absorb that. We've done, I'd have to ask Steve at Vermont, but I bet you he's done 6 to 10 homes with tilt and turns for custom homes, you know, where they wanted higher performance.
Is it twice the performance of a
R5 to an R7.
Okay. Okay.
Yeah. Well, I think, Peter, you've given us a remarkable evening. Unfortunately, I have to confess that Gio and I have never, ever been able to get these students this animated. We're just lucky if we can keep them awake mostly. And you got questions and thoughtful remarks out of every one of them. So thanks for making us look bad.
Oh, I appreciate the invitation. This is a great group. I love the dialogue, so I appreciate it as well. It's good to have these discussions.
Well, I'd heard that you were doing great things, but I had no idea how great. This is a wonderful evening, and you may have to suffer through me beating down your door to hear more. I saved some of my more personal questions for later.
Okay, great. Happy to talk again.
And thank your family for this evening. I mean, it's a gift.
All right.
Okay.
Well, great. Well, thank you, everybody.
Thanks, Peter.
Thank you, Peter.
Everyone's time. Have a good evening.
Thank you.
All right.
Folks, the rest of you should stick around for assignments and stuff. And that was a remarkable download.
Nicely done, too.
It's really set the bar high.
Yes.
It's also sort of used up our evening. So, but it's great to see.
It was definitely worth it. It was worth it.
Yeah. Oh, absolutely.
I mean, I love the cause behind it. I mean, I think that really speaks to my heart. I mean, I think it's a wonderful company in terms of what they're trying to do and what they've achieved.
Peter's been on the front of trying to fix the way we make our built environment since the day he walked into Vermont, and he was ahead of the LEED program. He was ahead of the Passive House program, and with the Passive House program, he migrated into the affordable housing and just the housing issues statewide. And he's an engineer by training, so he goes at these problems with a real nuts and bolts kind of approach, and it's great to see the success that he's had.
John, I didn't quite understand his association with Vermont. Is he a founder of it? Is he?
No, well, he works at a government level and always has, and so he was instrumental in bringing together funding agencies and sort of a team of people who could assure the Vermont company a fairly safe launch. But I was mentioning to one of you that, you know, we have a client a private client that we're working with. Gio's been the job captain on this, and he's been taking them through the factory, which is exactly as depicted in Peter's his slides. That is a fabulous factory to visit, and if any of you can get to that factory, it's fabulous. It's easily probably the most advanced factory in terms of thinking, at the same time as being one of the most primitive factories in terms of technology. So it's a very interesting. I just was at a symposium where everybody was talking about the use of more sophisticated digital and informational technology to give us better mods for less price and one thing and another. But the thinking behind the discussion was nowhere near as elevated as what has gone on in the Vermont story. It's similarly with the preferred building systems, although not nearly at the level of Vermont, which is much more advanced. So yeah, it's a great story, and will continue to be. And Gio and I will continue to report as we go through the project that we've got there, because it is much more similar to one of your projects in the sense that it's for a couple, it's a private home specific to a special site, it's larger, and they appreciate all the energy benefits, but that's not really what they're about. What they're about is living a certain way on their piece of property. So and they have a very finite budget. So it's a good example.
Is that the first?
Probably, I wonder if it's too much for me to suggest that we put together a little presentation of their home. Once it gets further down that, I'll talk to Gio about that and probably, serve him up a bunch of wine and have him commit to that presentation.
No problem. No problem. No problem.
All right. Gio, where does this leave us for next week?
For next week, where does this leave us for next week?
I mean, we didn't and don't have time to go over each of your projects, and I know that you've all made progress. It may be that next week we are as focused on presentations and reviews as we were this week focused on Peter's presentation. Does that sound appropriate?
Yeah, it does. What we have is we have the 18th, today's the 25th.
Can't hear you, Gio.
You can't hear me?
No.
Hang on a second. Why can't you hear me?
You just
Can
have
you hear me
to.
now? Can you hear me now?
Yes.
Can you hear me now?
Yeah.
Can you hear me?
No,
now?
I can't hear
Hang on
you.
a second.
Yeah.
All right, wonderful. I thought you left. You said goodbye and you came back. Nice.
Sound like you were going to say something important,
All right. Anyway, this is our after this class we have 2 weeks of work weeks. So during these 2 weeks, myself and John will encourage you to get a hold of us, set some time aside, and let's look at your projects so that we can try to bring you up to speed or help you with whatever issues you have, whether they're Skype or your design or I'm hoping that everybody at least found 3 modular prefabricators, panelizers in your area, because we wanted you in the first 2 lessons to approach them or go visit them. And in fact, that's what we'd like to encourage you to do is select 3 manufacturers and take the time and go visit them. Don't worry about, making it seem that you're not wasting their time. You're interested in building a home, you're interested in using a systems approach, whatever system that is, and speak to them and ask them and have them take you through their factory and have them and speak to them and ask that. We gave you a list of questions at the end of the first lesson that you should be asking them, just general questions so that you can get informed. And it would be good when after the 2 weeks are up, when you get back, if we can go through some of these manufacturers that you visited, and you can tell the class what you found out, and we go from there. In the meantime, we do want to encourage you to get a hold of us so that we can help you if you need help with your assignments. John, are you still there?
Yep.
Okay.
That seems exactly like the right thing to do. Just to underline that, I know a lot of you are sort of nervous about approaching these factories. I just came from a symposium of a bunch of factory. Basically, it was a symposium. It was an inside industry symposium. So it was me and a few others presenting 2 factories, and one of the so there was about 80 people in this room from different factories all over the East, and the thing that I explained to them in my presentation, that I encouraged my students to avoid the sales representatives. And they all looked at me and said, why? And I said, because mostly the sales representatives don't know the details and the nuances of the products that the factories are selling. And every factory agreed. They all agreed. They said, yeah, you're right, but you know, it's so hard to get them. Part of my reason for being at this symposium was to promote education for builders, site builders who are going to build their first modular home. Here's a stunning statistic I learned at that symposium. 80% of the conventional builders who embrace a modular home for the first time say they'll never do it again. 85%. And the reason is because their expectations are so unreasonable, that they think that it's just going to, some of them, and that's true of the homeowners too, they think the thing's going to just arrive on this truck and, you know, a half an hour later, they're going to be able to walk in and sit down. And, you know, it doesn't take much education to get people closer to reality. So my pitch was, gee, it'd be so great to have an educational program for first-time builders, so they would know what they were getting into and could expect it and could come away from the experience, you know, uplifted. And somebody in the audience said, and the building reps too, they should have to go. And the reason I'm bringing it up is because if you have any nervousness about going to factories, any factories, and saying, look, I'm taking a course and I'm thinking of building this building and, you know, could be a long way off. Don't feel bad about wasting the sales rep's time. They need the training. They need you. They need you to ask questions. Otherwise, they have no clue. Gio and I are here to make sure you don't fall into their clutches and actually buy their malarkey. But go there and get a sense of it. I mean, it's like buying a car. You don't do it often enough to be good at it the first time. It's too complicated. So just go ask the questions. You'll learn a lot.
Very true.
Yeah.
Cool.
All right, folks. I think that's it for today.
Yes, it is.
We will await your phone calls.
Or your emails. So don't be afraid to email.
Or your emails. Yeah.
All right.
Good night, all.
Good night. Thank you.
Thanks. Good night.